right, this will be our last example from section 8.1. And the way that we're going to solve this, we'll do two different methods. One method will be using substitution, and the other method will be using matrices, which actually we go over in section 8.2, so you might want to watch those videos first, maybe come back to this one. Anyways, we've got a theater that sells 3 types of seats. You got main floor, balcony, and mezzanine. Here's the information about how much each ticket costs. Main floor is $55 per ticket, balcony is $44, mezzanine costs $26 per seat. Here's some information about the total amount of money you made, $62,715 by selling all these tickets. And here's some information about how the number of tickets sold is related. And then the question is how many of each type of ticket were sold. So first let's write down what our unknowns are. Let's use X, Y, and Z. I would use M and B, except for there's 2 types of tickets that start with M, so I'll just do X, Y, and Z. Let X be the number of main floor tickets sold. And remember, those cost $55 each. And let's let Y be the number of balcony tickets sold. And might as well write down that those cost $44 per ticket. And let's let Z be the number of mezzanine tickets sold. And again, we'll remember that that's $26 per ticket. All right, let's write down the information that we were given using some equations. So one night, the sales totaled $62,715. So that's telling you that the amount of money you got from main floor tickets, which will be 55 times X, plus the amount of money from balcony, which will be 44Y, plus the number of money from the mezzanine sales, which will be 26Z. That all adds up to $62,715. All right, the next sentence says there were 84 more main floor tickets sold than balcony and mezzanine tickets combined. So this tells you the information about the number of main floor tickets. So X, it'll be 84 more than balcony and mezzanine combined. So that'll be balcony and mezzanine, number of those tickets, plus 84. That'll give you the number of main floor tickets sold. All right, and then the number of balcony tickets sold is 121 more than 3 times the number of mezzanine tickets sold. So the number of balcony tickets, that'll be Y. It'll be 121 more than 3 times Z. So I'll take 3 times Z and add 121. That'll tell you the number of balcony tickets sold. So here's my 3 equations. We'll do 2 methods. Method 1 will be solving by substitution. This screams out to me just because I have Y by itself here and X by itself here. I can kind of like back substitute. First, replacing Y with 3Z plus 121. This tells me that X equals Y, which is 3Z plus 121. So that's Y here, plus Z plus 84, which simplifies to X equals 4Z plus 121 plus 84. I think that's 205. All right, and now that I have what X is equal to in terms of Z and what Y is equal to in terms of Z, let's plug both of these into that first equation. Let's write down what we get. So 55X, so 55 times X, and X here can be written as 4Z plus 205. Plus 44Y, which is 3Z plus 121, plus 26z equals 62,715. All right, and again, the reason why I did this is just because I see x and y here by itself, so I can rewrite everything. Now I just have one variable, just the z by itself in this equation. All right, let's go ahead and simplify. Get 55 times 4, what's that, 220z, plus 55 times 205, that's 11,275. 44 times 3 gives me 132, plus 121 times 44, what's that, 5324. And then plus 26z equals 62,715. Kind of an annoying problem, but totally doable. We can add up all of the like terms. Let's see, 220 plus 132 plus 26. We get 378z plus 11,275. I'll add that to 5324. We get 16,599, and that equals 62,715. Let's subtract 16,599 from both sides. And we get 378z equals 46,116. And dividing both sides by 378, we get z is 122. So now I know we've sold 122 mezzanine tickets, and I can just go ahead and use these equations here to solve for y and x. So I'm going to go ahead and circle that. Y will be 3z plus 121, so 3 times 122 plus 121. You get 487. And then I can take both of these and plug them into this equation for x. X equals y plus z plus 84, or we could have used 4z plus 205. So 487 plus 122 plus 84. I get 693. All right. Now, you will want to put all of this back into the wording of the problem. So, we sold 693 main floor tickets, 487 balcony, and 122 mezzanine tickets were sold. All right, so that's the answer that I got by doing substitution. And again, usually when I have 3 or more variables, I might not choose to do substitution just because all of this kind of takes a long time. Let us actually look at the second method. So I am done with this problem. We have our answer, but I would like to talk about method 2. This is the method that we're going to learn in section 8.2 on matrices. I would actually just take this system and I'll write each equation in standard form. So all the x, y, and z on the left and the number on the right hand side of the equal sign. So the first equation is already in standard form. Okay, the second equation here, if I subtract y, subtract z from both sides, get x minus y minus z equals 84. And then this third equation, y equals 3z plus 121. If I subtract 3z from both sides, I'll get y minus 3z equals 121. And now these three equations are in standard form. So what I can do is put them into a matrix just by using the coefficient, all the x coefficients, y coefficients, z coefficients, and then the number on the other side of the equal symbol. So I've got 55, 44, 26, 62, 715, 1, negative 1, negative 1, 84. And here I don't see the x, so the coefficient is 0. So 0, 1, negative 3, 121. So there's my matrix. And I will put that matrix into my calculator by using the matrix button. And all of these steps are laid out for you in the videos for section 8.2. So we go to edit. And I want to edit, this is again 3 rows, 1, 2, 3, 4 columns. So it's a 3 by 4 matrix. And the entries are 55, 44, 26, 62, 715. Then I've got 1, negative 1, negative 1, 84. 0, 1, negative 3, 121. Okay, so now that I have all of those entries in my matrix, I'll go ahead and exit out. And then what I want to do is put this matrix into what's called reduced row echelon form, RREF. So I'll select the matrix again. This time I'll scroll over to math, and I'll scroll all the way down until I see RREF. And then I'll hit enter. And now I need to put the matrix inside of there. So I'll go down to select the matrix again, second matrix. And I will select that matrix that I just edited. Close the parentheses, hit enter. And now I have it written as a matrix in reduced row echelon form. 1, 0, 0, 693, 0, 1, 0, 487, and 0, 0, 1, 122. And notice what this says. X is equal to 693. 693 main floor tickets. Y equals 487. 487 balcony tickets. And Z equals 122. 122 mezzanine tickets. So this might have been a little bit shorter, a little bit less work to get the answer to the problem, and you still get the same exact numbers.